I'm Laura from NGU, and I'm here to welcome you to Go for Pythonistas. We have Francisque Campoy Flores, and he's going to correct me if I was wrong, who joined the Go team in 2012 as a developer program engineer after several years doing Python and C++ development. His mission is to make Go useful and fun, which you might be able to see from his shirt there. And he's on Twitter as his first name, as you can see up there on the screen. Thanks, guys.
Hi. So yeah, almost there. It's Francesc, not Francisque. It's pretty close. No problem. So yeah, I'm Francesc. I'm a developer programs engineer for the Go team here in Mountain View. And the goal of this talk is making you live with eager to learn more about Go. So first of all, how many of you know about Go already? Have written a little bit of Go? Cool. And how many of you use Go as their language at Google? That's cool. Okay. So I'm going to try to convince you. I assume that you all are Pythonistas, since this is a PyCon. So I'm going to be talking about Go from the point of view of a Pythonista in two ways. The good way, how Go and Python are very similar, and the more interesting way, which is how Go and Python are not the same. So a little bit about me, really fast. I joined Google 3 years ago. And before that, I was doing C++ and Python. And then I joined Google. And I was working in the ads backend team, doing C++ and Python. And 1 year and a half ago, I joined the Go team. And since then, I've been doing a lot of Go. So I have way more experience in Python than Go. But somehow I prefer Go. OK, so I'm going to start with the bad news. These are the things that I don't like about Go. And not too many, so deal with me. So the first thing that I don't like is the fact that variables can change their types. That makes your code complicated. You never know what you actually have, the value that you have for a given variable. So you can do a equals hello, and then a equals 2. And then when you try to do a, and you say, yeah, I'm going to get the first character of a, well, that may work, or it may not. Depending on what you have at the moment in there. But on the other side, it's actually very nice, the fact that you can have this very compact syntax where you don't have to say that hello is a string. It's obvious that it's a string, so you don't have to repeat yourself. And compared to other statically typed languages like Java or C++, where you end up having foo equals new foo. And if you have templates, then you have foo between brackets and all of these things. What we have in Go is actually a mix between both, and we have inferred types. So meaning that variables have a type, and they don't change. So once you say that a variable is a string, it will be a string for the rest of the life of the variable. But the type can be inferred. So in this case, when you say I colon equals, it means I want to declare and initialize a new variable, and I want to infer the type out of the value that I'm assigning. So in this case, hello, it's obviously a string. So a will be a string. And then if you try to do a equals 2, that won't compile, because 2 is not a string. You can also do b colon equal 1, and that will infer the type for 1 is an integer. So it will be just type int. Actually, Python is it's dynamically typed, but it's not because there's a hard feeling or thinking that it's actually better to have dynamically typed. Guido van Rossum has been working lately in a new project called MyPy, which is Python with static typing. It's a very interesting project. You can find it. I will share the slides afterwards so you have all the links. The thing that I like the least from Python is the fact that sometimes your program might get to some spot where it's the first time that you go through and everything explodes and you get runtime pyrotechnics. So let's see, for instance, in this code, 50% of the time, this should print, hey, Pythonista, you win. And the other 50% of the time, that's just going to explode. So if you run it, it starts exploding. Why? Because I misspelled name and I wrote name. These things, yeah, if I run it again, that should work. Yeah, there you go. Second time it works. So the problem with this is that it means that when you're handling errors, all these corner cases, very often, if you don't try them and you don't test them thoroughly, having 100% of code coverage, you won't be able to make sure that everything works perfectly. And for me, that's a symptom, that's a smell of the language. And it means that there's some people that try to find the 100% coverage as a metric that you have to reach to make sure that your program is correct. And there's two problems with that idea. One is that it's not because you do 100% code coverage that your code is correct. You can have very bad testing with 100% coverage. And actually, 100% coverage, the code coverage should be just something that allows you to find the spots of your program that have not been tested, rather than making sure that everything is spelled correctly. This actually, I'm not going to say more about this. There's a lot of discussion about dynamic, static, all of this. So, and other things that I don't like, this is the last slide about things that I don't like. I don't like when you deploy something and you miss a dependency and then it doesn't work, or you're running on a different environment, you're missing stuff. With Go, you compile to a binary. So deploying the binary, just copying into a server and just executing the binary. You cannot miss stuff, except if you're using C++ and you're doing all the things in the middle, and then you actually have external dependencies. But that's another case. Then performance. Guido said that Python is not too slow, which is fair enough, but not too slow, it doesn't mean fast enough. And then magic. Magic meaning underscore, underscore, magic, underscore, underscore. So all of these methods that have underscores, which are very powerful, but they actually allow you to do a lot of really cool things and dangerous things at the same time, like redefining what you do when you're missing a method. Meaning that then you misspell the method and magic happens. So there's actually this page is pretty cool. It's a list of all the magic methods in Python. And that's everything I don't like. The rest, I love it. Ooh. So I like concurrency. And I tried doing concurrency on Python. And I learned about the global interpreter lock. And I'm not going to say much about it. You can watch this talk. It's an amazing talk. It explains how the global interpreter lock is an amazing thing, and it's horrible at the same time. So I won't explain more, but the problem is that doing actual concurrency in Python is really complicated. There's a lot of really big restrictions. Now, things I like. The first thing that I like is the Zen of Python, that I guess you all know perfectly. And actually, there's even a talk that Andrew Duran from my team gave. It's Go and the Zen of Python, where it tries to find how Go matches the Zen of Python, and we found out that it matches pretty well, even better than Python, some said. Also, the fact that hashes and arrays are part of the language, they're really, really useful. And for someone that comes from C++, it's actually a really big thing. The fact that you don't have to decide what kind of set you're going to use. You use set, and that's it. If you need something more specific, you can find it. But the basic stuff, it's already in the language. And that's something that we also have in Go. Slices and arrays and maps are part of the language. And it's something that is really useful. The standard library, even if, in my opinion, it's difficult to find what's in the standard library sometimes. The documentation is a little bit different, but I think it's more a personal, I'm used to other kind of libraries. But it's really complete. You have everything that you need in the standard library. And in Go, we think that you have pretty much everything. We're sure you don't have everything, but it's actually mostly everything that you need in your day-to-day HTTP servers and encoding, decoding of JSON, XML. All of that is already in the standard library. And then magic. I actually like magic in Python. You can do really, really cool stuff, and some lines of code can take you really, really far away. So when you are able to handle that magic correctly, magic is cool. The problem is when it goes wrong. So I'm going to stop talking a little bit. I'm going to show you a little bit of code. First, Python code. So I guess that you've heard about Fibonacci before, maybe. So this Fibonacci ran in Python. So we have two versions of Fibonacci. One is the one with the loop, where we just iterate n times, computing the next Fibonacci number. We return it. The one which is the recursive version, which matches more like the mathematical definition of Fibonacci series. And then we can go it, and it works. Yay. Now, let's see this in Go. Now, it's a little bit longer because instead of colon, we have brace opening and brace closing at the end, so it's 3 lines longer. Other than that, it's actually the same number of lines. And if we pay close attention, actually, so we have the fib function. Fib function is a function that gets an integer and returns an integer. How do you know it? Because you know it. It's in return b, and b, it's an integer somehow. So in Go, you say fib is a function that gets an integer and returns an integer. And you have 2 variables, a and b, of type integer, since the values are 0 and 1. And then you do the loop n times and return b. So pretty simple. For the recursive version, it's very similar. Again, you just if n is 1 or less, you return 1. Otherwise, you call the Fibonacci function twice with n minus 1 and minus 2. And you can run it, you get, of course, the same result. But the important thing here is that actually, if you know how to write this, writing this is actually pretty obvious. It's pretty much the same thing. The syntax, other than the colon replaced by the braces and the for loops are slightly different, pretty much you can do pretty much the same thing. Now, if you're doing Python and you write a Fibonacci function, you will end up having a generator. Everybody loves Python generators, me included. And they're actually really cool because it allows you to write something like this. Say the Fibonacci function is a generator, and what you do is instead of returning new values, you just do yield. And then when you do yield, that means that you are returning that value, but not really returning because you keep the state of the function where it was, and then you keep on executing where it was. So you somehow have this thing here, where you have the main function and the Fibonacci function, and actually they are kind of living at the same time. There's concurrency. And how would you do this with Go? Well, it's concurrency. It's not parallelism, but it's concurrency. You have two different processes working at the same time. And with Go, how are we going to do this? Well, we're going to do it with concurrency. Go concurrency has 2 main concepts. Gophers, no. Go routines and channels. So here the Go routines, you can imagine that the gophers, and they are the ones that do stuff. Go routines are very, very light threads. So they're not actual threads, they're coroutines handled by the Go runtime. And you can have thousands of them inside of an OS thread. And then to communicate between them and to synchronize, they use channels. And channels are the arrows between the gophers. And a channel is just a pipe that is typed. So you can say, I have a channel of integers, a channel of booleans, or a channel of channels of integers if you want to. Maybe. And now that means that we have pretty much the same schema as we had before. We have main and fib as before. But now instead of communicating directly through yield and calling the function through next, now we have this channel in the middle. And the Fibonacci function will send values into the channel, and the main function will receive those values from the channel. And at the end, the Fibonacci function will close the channel, notifying the consumer that, OK, we're done, there's no more values. And then when you read that, you will actually get the default value for the type that you're reading. So if it's integer, it would be a 0. And the Boolean would be false, meaning that it's actually, the channel is closed, so stop reading from here. So how do we write this in code? This is pretty simple. So where we had yield before, now we have this C with the arrow coming from A to C. So we're sending A into C. And what is C? C is a channel of integers. And that's it. Except for the fact that at the end, once we're done, we say, OK, we're done, closing the channel. So at the end of the Fibonacci function, we close the channel. Now, that's the definition of the function. But this function, we have to call it in a different Go routine. Otherwise, we're going to only have one Go routine. We're going to get to the channel. We're going to try to write into the channel, send something into the channel. And if there's no one receiving that, we just block there forever. So that could be a deadlock. So we have to execute that function in a different Go routine. How do we do this? Just adding Go. So when you add Go to a function call, that function call will be executed in the background in a different Go routine. So that means that as soon as we call that Fibonacci function, we start doing range. And range of a channel, what it does, it reads all the values from the channel as long as the channel is open. And when the channel closes, we finish the loop. Okay. So if we run this, there you go. Now, in the main function, we create the channel, and then we call the Fibonacci function a different Go routine, and then we start reading from it. And what happens if I forget this? Then it doesn't work anymore. What if my programmer forgets about this? We should actually hide that and make it more Python generator style. So what we can do is just move the creation of the channel and the fact that we're creating a new Go routine into the fit function. So let's see how to do this. Whoop, I missed one. So now the Fibonacci function, now it returns something. And it returns a channel of integers that is created at the beginning of the function. And now all the code that was part of the Fibonacci function before, it's surrounded by this Go func with the braces. So the func with the braces, it's a function literal. It's kind of similar to what people call lambdas. Not really a lambda, but very similar. And so we have this function literal, and we're calling it. That's why we have the parentheses at the end. And we're calling it in a different Go routine. That's why we have Go before the func. And then we return C. So we're doing exactly the same thing as before, just arranged in a different way. And that allows us to have something like this for x on the range of fit. So now this is actually very, very similar to what you could see in a generator. And still works. Yes. OK, so yes.
Range?
So range works in some different types. Range on a channel, what it does, it receives all the values from the channel as long as the channel is open. And when the channel closes, you exit that iteration.
So for range, that's like a single construct.
Yeah, that's a statement. It's a for loop with a range. It's something. You cannot use range outside of a for loop. Yeah. So if you have a computer, we're going to do an exercise now. Yeah.
I have a question on the previous
Sure.
slide. Make channel. So it looks like channel int looks like a type.
Yeah, channel of integers is a type.
Type can be parameter of the function.
No. No, types, we have types that you can pass as parameters of the functions from the reflect package. So it's reflect, how do you call it? It's autoreference. So you can actually find out about the reflection. This case, make is a special function. It's similar to new. So it's the same way you do new of int, you can do make of a channel. Okay, so we're gonna write this exercise, and you can actually find the code for it if you want to do it on golang.org/s/go4py-exercise1. I guess you can read it. And this exercise is running a generator, so something very similar to we had in the slide before. But instead of returning Fibonacci numbers, we're going to return n prime numbers. And I'm already giving you the definition for the prime function, which tells you if an integer is prime or not. It's definitely not the best solution to find if a number is prime or not. There's more efficient ways, but it's good enough. So do you want to do the exercise, or I can do it with you line by line? Let's do 1 minute, and then I'll go through it. And in the meanwhile, if someone has a question. Yeah.
Just a minor point, but your first example, the typo, that would be probably caught by Pylon.
Yeah, definitely. I mean, there's tools on top that that will allow you to find.
And the second thing is we're working on tools to do the much more sophisticated type inferencing and generating information.
Yeah, the link that I have to MyPy, actually,
By the way, it's not done by Guido.
he pointed me to that
pointed
as
to it, but
he
not
was
by
the one
us.
working on it.
At Cambridge.
Okay, that's what Guido said. So, but yeah, it's really cool because it allows you to add static types without forcing static typing on everything. So you can say this is actually static type, and the rest, everything that can be checked will be checked. And if you cannot check something, we'll just let it do dynamic typing for that. So this is a playground, very useful if you want to share code or run any kind of Go code. You don't have to install anything. Just go to play.golang.org.
That's server written code. Yes.
No, actually, I think it's written on C on Knuckle now. It's been, oh yeah, it's done. Awesome. It's only done when I do talks. Yep. Okay, so it's done. That's great. Okay, so let's go through the solution anyway, since you cannot really try it, but gonna just write it here directly with you, line by line. So we have to return a channel of integers. So the first thing that we have to do is create that channel of integers. So we can do make a channel of integers. Now we will end up returning it. Now we're just missing thing in the middle. So what we have to do is start from 2, and as long as we're not done, if a number is prime, just send it into the channel. So this is an infinite loop in Go. We'll have while. We have for, which is it's 2 letters shorter and therefore better. So yes. So you can actually we can do well. We have still to generate from 2. Okay. So if I is prime, we decrease n because we found a new prime. And yes.
This should be I smaller than n?
No, because what I'm doing is, so n is the number of primes that I want to generate. So I'm decreasing it every time that I find one. And we put that I number, which is a prime, into C. And that's it. And now if we run it, is it gonna work? Is the server still down? Maybe. Yes. Well, this couldn't work. Yeah, that's the point. This couldn't work, and it couldn't work because actually we don't have concurrency here. We still have only one Go routine. We should execute the body of that loop in a different Go routine. How do we do that? We just do this a new function that we're calling. And this is actually still the same thing as before. We still don't have concurrency. To add concurrency, we just go. So we're saying, I want to execute that code in a different Go routine. And now that should work, except for the fact that the server is done. But I can prove you that it works because it's here. And that's on my local machine, and my local machine works. Yes. So that was the first exercise. So this is actually very similar to generators. Now, there's also generators in Python that you can have generators that get values also. I tried to understand it. It's actually pretty complicated. But pretty much you can have this idea of generators that get values and return other values, which is pretty much like filters. And that's the next exercise that I'm asking you to do, that I will do with you, actually. And it's the idea of we are going to have a function, filter primes, that gets a channel of integers and returns a channel of integers. And what it's doing is reading receiving values from the input channel, checking if the value is prime, and if it's prime, and only if it's prime, it puts it back to the other channel. So if you send 2, that will pass. If you send 4, that will not pass. And at the end, when the input channel closes, it closes also the output channel. So then you can use something like this. Say filter primes. I want to get Fibonacci of 20, so that will generate the 20 first Fibonacci numbers. And out of that, I want to filter the primes. So I want to get to all the primes and print them. And I'm going to write it here again. So we're going to go line by line. So we have this filter primes function that gets an input channel, which is a channel of integers, and returns a channel of integers. So what we have to do, the first thing, create that channel of integers that we're returning. So we're going to call it out. It's a channel of integers, and eventually we'll return it. And now we have to receive values from the input channel and write them into the output channel if they're prime. So how do we read values from the input channel? Like this. We're just iterating over all the values in the input channel. And if the value is prime, then put V in the output channel, and at the end, close the output channel. And again, we execute that in a different routine. Expected, oh yeah, thank you. Wait, but that worked. Maybe it's working? No, not working. Nope. But again, the code is here. So I can show you, it actually works. And something that I think is pretty cool is the runtime is able to find out when you are in a deadlock. So imagine that we forget to close the output channel. That means that this main function will actually be locked trying to get new values because the channel has not been closed. So maybe new values will come later. So we're still there trying to receive values. But there's no other Go routine that has access to that channel. So no value will be written there. So the runtime will find out that for you. And oh, yeah. So it will actually work because the code is not being taken into account. It's a pity that doesn't work. But so I can do it here. Imagine that we forget to close this channel and we run this. You could actually get all the values, and then at the end, the fib function ends, that Go routine dies, and it's garbage collected and everything. We don't have any more reference to that channel, and we have a Go routine blocked, trying to receive a new value. And the runtime knows that there's no possibility that someone will write anything into that channel. So there's only one Go routine, and it's sleeping, waiting for new values. And even if it was more than m, if all of the Go routines are sleeping, waiting for channel operations to happen that will never happen, that's a deadlock. So you will actually get a message saying all the Go routines are asleep. That's a deadlock. And you cannot see it here right now. Oh yeah, there you go. So you will get a stack trace of all the Go routines that were alive at that moment and what we were trying to do. So this is a very simple way to debug your program. It's not really debugging, it's actually just crashing. Like if you get to that point, you're really bad. But we also have the thread sanitizer that is also very useful if you want to find that data condition, race conditions. You can do the Go thread sanitizer. And so with channels, you can do generators, but it's not the only thing that you can do with channels and coroutines. There's a lot of different things that you can do, a lot of different concurrency patterns. And there's two very good talks, one given by Rob Pike, Google I/O last year. So you can find the link. I will publish these slides so you can find it on YouTube. And then by another one by Samir Ashmani, also from the Go team, that was on the Google I/O this year. Now let's see a little bit about object-oriented Go. Go is object-oriented, but we don't have inherit, implement, or class. So let's see how it is. Yes. So in Go, we have types. And we don't have classes. Instead, the most similar thing to a class could be a struct. But a struct is just a list of fields. So in this case, we have this type, name, that has 3 fields. They're all strings. And there's the first name, the middle name, and the last name. And you can declare methods on types by using this syntax. So we're saying this is a function applied on this receiver. Okay? So in here, the receiver is name, and we call it n because it's a name. And then we give the name of the function, the parameter list, and the results. So this is actually pretty similar to, in Python, you could have something like def string self, but that self is actually moved before the name. It's actually explicit. And we don't call it self. That's idiomatic. You can call it self if you want to. But normally we call it something that actually matches the name, the type name. So in this case, name and n could work. And that's it. So in here, we're just returning a string that is the first name, the first initial of the middle name, and then the last name in uppercase. So if we can create this struct. That's the type name. And then we give 3 values, William, Mike, and Smith. So if we run this, printing the string resulting from calling string method on n, that will print something like William M. Smith. Okay, very simple. Yes?
Are you targeting Python structures by value?
Not always. It's a possibility. You could also do pass by pointers, and then you're not copying the structure. Yeah, it's a long discussion. I'm not gonna get into details. I'm not trying to teach you Go. I'm trying to make you want to learn Go. Different. And you can declare methods not only on structs, you can declare methods on anything. So we can declare a different type, which is a very simple name, which is just string. So type simple name, string. And then we can declare a method on that. So now we define the method string that you can apply on the simple name. And now you can have a method type, which is actually a string, on which you can call string that returns a string, which is kind of silly, but it works. So you cannot declare methods on anything. You can declare methods on any kind of type, but they have to be declared in the same package as you are. So you cannot add new methods or modify methods that are defined in types outside of your package. So modifying the string type, for instance, that you can do in other languages, there's no way you can do that in Go. Okay, duck typing. So duck typing is one of the most awesome things of Python, in my humble opinion. I guess that you all know what duck typing is. Just in case, duck typing is this phrase: if it walks like a duck, what else? So are you sure that you know the whole list of the features of a duck? Okay, that's my point. So in Python, knowing what defines exactly a duck, it's not easy. You have to think about it. And what if the duck is not exactly a duck? And what if we're not talking about ducks, but the file-like object. What is exactly a file-like object? Where can I find a list of that? Is there a list in the code that defines that? So what if the duck is not a duck? It will fail in the runtime. I think it's a very cool, pretty cool picture. So in Go, we have something pretty similar to duck typing, but it's not duck typing. We have interfaces. So interfaces are just a list of methods. So in our case, the case we were defining before, we had the method string that returns a string. There's actually an interface called stringer that has only one method, string, that returns a string. And it's part of the fun package. And that's a very simple interface. Actually, in Go, most of the interfaces are very, very small. Very often, we have only one method, like write, and then it's a writer, or a read, and then it's a reader. And the fun package knows about this interface. And it has a case, special case. It says, OK, so when you're printing something, if that type implements the interface stringer, I will call the method string and print that instead of printing something else. So now actually you can do println of name. And that prints William M. Smith, which is surprising because we didn't say that name was a stringer. But in Go, interface implementation is implicit. If you implement all the methods of an interface, you implement that interface. So actually, both those two things together, interfaces and implicit satisfaction of interfaces, allows you to have something really similar to duck typing. What's the difference with duck typing? The difference is that it's not just it looks or it walks like a duck. It's actually, we know it's a duck. At compile time, we check all the methods that you're declaring that type has. And if any of those are missing, you will get an error message. Something that I really like too, decorators. How many of you know what decorators are? OK, all of you. I didn't know what they were. But so decorators are something that are really useful because they allow you to add behavior to an existing function. So in this case, we have this doGet function, which is actually a method of the myHandler class. And we add this at auth required. And what that's going to do, it's actually modify the doGet value by wrapping the body of this function with another function. So how do we define that? So actually, using it is very simple. Defining it is not that simple. Defining it, you have something that's a function that gets as a parameter a function and returns a function. So we're returning check user, and check user is a function. And in that function, what we do in this example is we're getting the URL parameter. We look for name, and if name is there, then we do some monkey patching, or we put that username into the object, and then we call the function that we had at the beginning with that object. So that means that when we have a HTTP request, which will be self here, before doing self write, actually we're going to check if the user is there. If the user is there, then we will eventually get here. But otherwise, we'll just print unknown user, and this function will never be executed. Okay? So that's decorators in Python. So then you can just run it, and if you access it directly, it says unknown user. What happened here? We actually executed the part where the function is not even called. Actually, we checked user is not there, print an error. And if we pass something else, it will actually work, and we'll execute the body of doGet. So that's cool. So can we do that in Go? Yes, otherwise I couldn't talk about it. So we can do it, but not exactly. We don't have the at something. We don't have that syntax. But for the rest, you can pretty much do the same thing. So we can define a function. This is a function literal that does. So this is actually a function literal. It's a pretty special one. This type, it's an HTTP handler func. So this is actually the type that defines how HTTP server handle requests. It's a function that has two parameters. One is an HTTP request that contains all the data of the request, and a response writer. So the response writer is something where you can actually write the output, you can set headers, and all of that. And what we do is we just print hi, the username that we get from the request, and that's it. So this is actually exactly what we had before. And instead of the @auth required, we're just passing that value, because function is a value, we're passing it to auth required. And what is auth required? Auth required is a function that returns a function, which is exactly the same thing as in Python, except that here we actually write it. So we specify we're getting a handler func, which is a type, which is a function that gets a response writer and an HTTP request and doesn't return anything, and it returns the same type. And what we do is we return a function that, again, an HTTP handler func. What we do inside is we check if the user is defined. If the user is not defined, that string is empty. We send an error. So HTTP error will actually set, we'll print that error message, unknown user, into the output, and we'll set the status of the page to be status forbidden, which I think it's 404, maybe not. And then it returns. Yes?
In the previous example, the decorator actually stored the user in a field of the object. So what would something like that look like, the decorator method?
So I did that in the Python example, because getting the parameter was actually kind of difficult, so it was a lot of code. In Go, if you wanted to do that, probably what you could do is you could add a parameter into that function. You could add an extra parameter, could be the username, and then you could actually obtain it and call that function. When you call it here, f, you could actually do fwr name. So you can add more things on top. That's something that I've done, especially when you have some object that you have to decode and then pass it, things like that. That's really easy to do. So we have this authentication required that now gets a function and returns a function. And this is a HTTP server in Go. So what we do is we declare that all the things, all the URL, all the requests that go to a URL matching hi go to the hi handler. And hi handler is the authentication required version of this function here. And by the way, this HTTP package is the same one that runs the Google Google download page. So if you go to dl.google.com and you download any big binary, you will actually run in some Go code there. So we're running there. If we access directly without any name, unknown user as before, and if we pass a user, it will work. Now we have another exercise that we're not gonna do because the playground is still down. But in this exercise, we're gonna add, so in Go, very often when something bad happens, you return an error. We don't have exceptions. We have a mechanism that works like exceptions, but we don't use it as exceptions. It's panic recover. But instead, if something bad happens, you return an error. And if that error is nil, it means everything went okay. If that error is not nil, it means something bad happened, and you should handle that error. But the handler func that I mentioned before doesn't allow you to return an error, which is a little bit of a pity, because very often when something bad happens in any handler of your web page, you're going to do the same thing all the time. You're going to pretty much log the error and then show a big whale or something like that, depending on the company you work for. But you're going to do pretty much the same thing all around. So you don't need to have that code over and over all around. So how do we do this? Well, you can define a function that's just like a handle func, but returning an error. So that's what I did here. Type error handler. It's this exactly the same thing as a HTTP handler func, but it also returns an error. And then our decorator, what it's going to do is it's going to take the result of that error, and if the error is not nil, it's going to handle doing something. So it's going to log it and return an error message. So this is the handler that we have. So our handler, it gets the name. If the name is not defined, then it returns an error. Say something bad happened, I cannot keep on working, the name is missing. And otherwise, it prints hi, the name, and returns nil, saying everything went fine. Yes?
Does it capture the stack trace at the point of error construction, or?
There's packages to do that. By default, no, it doesn't. By default, normally what you do is you handle the error locally, and because stack traces are useful when you're not handling the error locally, and you lose the information. In Go, sometimes that happens, but when that happens, most of the time, you're going to use something special on top. An error is an interface that has only one method, error, that returns a string, so anything could be an error. So this handler, it's not the type that handler func expects, because it returns an error. But if we use handle error, which is this decorator function, now the result that it's returning, it's actually a HTTP handler func. So let's see very fast how this is done. And again, what we do is we return a function that matches a handler func. What we do is we call the function that returns an error, and if the error is not nil, we log it, and we show an error message, so oops. The rest of the code is just because on the playground you cannot run an HTTP server, which kind of makes sense. But anyway, the playground is not working, so I'm not going to explain why. So the last thing that I'm going to explain, monkey patching, also called duck punching, which is kind of cruel. It's something that allows you to modify functions of types and the runtime. And it's something that it's very useful, especially for testing. When you're testing stuff, sometimes you want to break dependencies on things that you don't want to test at that point, and you use monkey patching. So in this case, for instance, imagine that you have say hi, again, and this say hi checks if the user is authenticated. And that authentication function, it's using URL-lib, so it's actually doing a HTTP request to some authentication server. And then you want to test only say hi without testing this. You don't want to depend on a server running for your unit test. So how could you do it? So in Python, very simple. You get globals and you change the value, and that's it. So now auth, which is that function, it's lambda that returns true. And now I know that when I say hi, the authentication will work. And if I want to check false, that works. So this is pretty awesome, I gotta say. So we checked twice. The first one, it works. The second time, it says an authenticated user. So you can actually do this. Very simple. Can you do that in Go? Of course. The only thing that you have to do is when you define the func auth, instead of starting by func auth, you say var auth equals func. And now what you're doing is instead of defining a function, it's a function in the package, you're actually defining a variable, which is of type function, and assigning a type there, which means that then you can change it. So that means that then in our test, we can actually say auth, it's just a function that returns true all the time, or it's a function that returns false all the time. Yeah?
So is this applicable to member functions of those objects that you create?
So in Go, if it's external, internal or external, if it's exported or not for a type, it depends on the first letter. If it's a capital letter, it's exported. Otherwise, it's something private. So you could actually change it from outside of your package. It's probably not a good idea to allow people to do that. So very often what we do is you have the parts that you want to change at the test. There are normally implementation details, so they're not public, and you change them in your test code. And the test code is in the same package, so you have access to them. So yeah, this function test hi has to be in the same package to work. I cannot then, from some code in production, change the authentication method because I want to. So in conclusion, Go is like Python because it's fun, it's flexible, and there's a lot of really cool techniques that you can apply. And actually, programming in Python, I think it's fun. You can get a lot done really fast. But it's different also in the fact that in the fact that it's faster. It's very concurrent. Using concurrency is something that you do pretty much in every single program. Using Go routines and channels is something that you get to do pretty much in every single line of code that you write, and it's statically typed. Yeah, disclaimer. I think it was funny that I was talking about Python, ducks, monkeys, and gophers, and it's about programming. So the next steps, the external webpage, golang.org. You can find all the documentation of the standard library and a lot of documentations and to learn more about Go. Also the tour. The tour is an interactive tour that will take you through most of the features of the language without having to install anything if the server is not down like today. And then finally the community. So we have the external communities, Golang Nuts. Then inside of Google, the Go webpage for Google is go/go. That's easy. And then you will find all the information there. But we also have an internal group. It's Go Nuts without the Golang. It's go-nuts. So thank you very much.